Kia ora whānau. This is the final episode in a series of basic probability videos. This one focuses on visualizing the normal distribution. So there are about 3 key features that you need to be aware of or know about of the normal distribution. So let's get straight into this and hopefully everything will become crystal clear. So what we have here is a histogram. We've got time on the horizontal axis, you could say that's time in minutes, and we've got frequency on the vertical axis, or the number of occurrences. So for example, the time of 20 minutes was recorded 13 times. So the first question I want to ask is, calculate the proportion which is 30 minutes or more. Okay, let's see how this works. So, firstly we need to be able to interpret the graph, and we can see that that bar there has a frequency of 1, and I've written the totals for the rest of the bars there too. So in order to calculate a proportion, which is also known as a probability or a risk, okay, we need the total number of data points. So we're going to go ahead and add these up, and we get 59. So what we're looking for here is 30 minutes or more. So we're looking at those 3 points in particular. So the solution, we're going to take out 12, which is 9 plus 2 plus 1, and we're going to divide it by the total of 59, and we get our proportion. And that's our final answer there. This is the first question. We're going to consider 2 more questions. Alright, now this one gets a little bit heavy-handed, so you'll need to pay attention very carefully. So the question here is, why can this sample distribution be assumed to be normally distributed? Now I call it a sample distribution because the data that's represented on the histogram, you could say it's assumed to be from a sample of a wider population. Don't worry too much about that, just know that it's data. Alright, so the very first thing we need to consider here is the center. So that's where I think the center is. And according to our sketch of a sort of standard normal distribution, we want the mean to be right in the middle there. And we want it to sit where most of the data points are. And it looks okay where I've drawn that green line. So what I need to write down is the obvious central point, which is the obvious central point is in the middle of the sample distribution. Remember, we're trying to justify here why this distribution is normally distributed. So I've already told you it's normally distributed, but we're trying to come up with reasons why. So number 1 is we've got an obvious central point. Okay, and we can specify that. We can say it's about 20 minutes. And we don't need to be too accurate here. Our approximate is fine. Next thing we need to look at is spread. So notice on our sketch there, that sketch there I've done of the standard normal distribution, the spread is going to be even, both sides, or it should be pretty similar. So I hope you agree with me when I say that the spread is similar both sides of the green line, or both sides of the central point there. So that's what I'm going to write down there. The data is spread or distributed evenly. You can think of it as symmetrically, both sides of the central point. Last thing we need to consider is the shape of the distribution. Now I've taken my outline there and I've just sort of hit the top of each of the bars, and it looks very much like a normal distribution. But we need to actually be able to write down reasons why. So there I've colored in most of the data points, and what I've pointed out there is the left and right tail, but let's come back to that in a second. So I can say the majority of the data points are between 10 and 30 minutes, or in that central portion. Okay, and I can say that very few of the data points are in the left tail and the right tail. Now these are characteristics of a normal distribution. So these two things here, the fact that the majority of the data points are in between 10 and 30 minutes, and very few data points in the left and right tail, will tell me that the distribution is bell-shaped or symmetrical. And that's the observation we noted before. So these three things of center, spread, and shape should be what you need to have in your mind in order to answer a question similar to this. So let's consider one more case. Question 3. Why can't this sample distribution be assumed to be normally distributed? Now if you look at it, it looks nothing like the picture in the previous question. But let's get a little bit deeper. So first we want to look at a center, and there is no obvious central point. I can't find one that's going to suit this entire picture visually. I'm speaking here. What about spread? I'm going to park that for a second because I want to talk about shape first. So, in terms of shape, I'm going to argue that there are actually two distributions in this picture here. There's one on the yellow and one on the blue. Number one I can see is, number one is right skewed, and number two is left skewed. What I've also done is highlighted, so if I have two distributions, what that means is there's got to be two central points, one for distribution 1, one for distribution 2, or two means, you can think of it that way. So I've kind of highlighted that there for you. Hopefully that's not too bad for you. And if they have two central points, then that means there's going to be a spread, or the data is going to be distributed around those two central points. So there's two different central points, but it's also uneven. The spread is uneven for both distributions. Now if it's uneven, then we're going to result in a skewed distribution. However, because we've got two distributions here, it's never going to be normal anyway. And that's all we have time for. So thank you very much for watching. And that concludes the final episode in a series of basic probability videos. Tune in soon for the next season.